Hello everyone. Today I am going to explain about my project which is reinforcement learning for blackjack presented by Gautam Krishnamurthy and supervised by John Fayende. So in this slide we are going to explore about the world of reinforcement learning where machines learn to make decisions based on rewards and punishments. Well, positives or rewards and negatives or a bit kind of a punishments. So we will explore it further. Reinforcement learning can be applied in two-player playing games such as blackjack. So here's the project overview. Blackjack is a popular card game. We are building an excellent environment to apply and study the reinforcement learning techniques. The goal of this project is to build a proficient oral agent that can play blackjack against any given strategy. So this project has primarily four objectives: developing an oral environment, training and competent oral agent, enhancing the oral agent with best response strategies, and exploring advanced multi-agent reinforcement learning techniques and integrating into the agent's learning process. Let's dive into some background and related work. Reinforcement learning is a subfield of artificial intelligence that involves agents learning to make decisions by interacting with an environment. We have a key concepts including states, actions, rewards, and the policy. Several prominent works such as AlphaGo by DeepMind have demonstrated the power of oral in the mastering complex tasks and games. However, oral to a game like blackjack presents its own challenges due to its stochastic nature and the need for a balance between exploration and exploitation of all the techniques. We aim to overcome these challenges and develop an oral agent that can master the game of blackjack. So here is our problem definition. We all know that blackjack is a popular card game with a simple rules which attempt to get their card as close as to 21 as possible without going over. If the player's total exceeds over 21, they bust and lose the game. Our problem defined as follows. We, however, we can train a reinforcement agent to make optimal decision in the game of blackjack. The objective is to build a RL agent that through the process of exploration and exploitation, learns the optimal policy for playing blackjack. In other words, it learns when to hit and when to stand based on the state of the game to maximize its winning rate. So here we are discussing about the nutshell of reinforcement learning for blackjack. The agent is a player we are training. The environment is a game of blackjack. The states are observable aspects of the game such as the player's cards and the dealer's visible card. The actions are possible moves, hit or stand. The rewards are the outcomes of the game. If it's a positive one, it's win. If it's a negative one, it's lose. Or if it's a draw, it's zero. Here's our methodology. Deep Q learning, DQN in short, is the core methodology used in our project. DQN is a variant of reinforcement learning that combines with the traditional Q learning with deep neural networks. Our DQN agent starts with a random strategy, playing multiple games and learning from the rewards or penalties it gets. The difference with DQN is that it uses a deep neural network to approximate the Q value function, which is used to select the actions over time. And through the principle of trial and error, the agent develops a strategy that maximizes its rewards, that is, winning games of the maximum of blackjack games. Implementation. OpenAI GM provides the environment for blackjack, offering a ready-to-use framework for stimulating games and training the agent. TensorFlow was developed by Google was used for constructing and training deep queue network used by our DQN agent. The agent and the game environment interact through a cycle of actions, new states, and rewards. However, learning from its past experience and gradually improving its performance in the game. This process, driven by reinforcement learning and deep learning, allow the agent to develop an effective strategy for playing and winning the games of a blackjack. Here is the project timeline. The given Gantt chart visually represents these stages and they overlap, giving a clear idea of the project flow. Here is the project plan. The project initiation and background research. The project begins with the comprehensive review of existing literature review, and this helps the foundation for the rest of the project and the design of the RL environment. The following the literature review, it involves the designing of the blackjack environment that for our reinforcement learning agent that interacts with, and developing of the RL agent. Once the environment was set up, the next stage involved in the actual development of RL agent. This was the most significant piece of the project. And coming back from that, we are going to hyperparameter tuning and the training of the agent. This is the core part where we have to achieve the optimal performance and training the agent over thousands of the games to learn the optimal policy. From that, evaluation of the RL agent, and after that we are going for the documentation. During this phase, the focus was the documenting the project including the describing the methods used, discussing the results, and detailing the project success and failures. The challenges we put on to that was the final project presentation and project report finalization. So here is our system design where game environment, the blackjack was created to stimulate the game rules, keeping the track of the cards dealt to the player. RL agent, our agent was developed using deep queue learning. It interacts with the blackjack environment and choosing the actions on its current policy and receiving the rewards and the new state information and updating its policy based on the outcomes. And Deep Q network DQN. DQN was the core of the RL system. It was used to approximate the Q values for the state action pass in the game, guiding the agent's decision. DKN consisted of multiple layers and was trained using experience stored in the replay buffer. Replay buffer was used to store the agent's experiences. State representation. The states in our game were represented as a sum of players' cards and the dealer's visible card. The action space consists of two possible actions, whether it is hit or stand. And finally, training and evaluation. The RL agent was trained over multiple episodes of playing blackjack, with the agent updating its policy after each game. The agent's performance was then evaluated by having it play several games and tracking its win rate. Here comes the results and evaluation. The model performance present the results of the RL agent playing blackjack focus on the reward gained over a set number of games, include key metrics such as win rate, loss rate, and draw rate. And training process display a graph showing how the agent's performance evolved during the training process. The x-axis could represent the number of episodes and y-axis could represent the average reward. Benchmark comparison. Compare the performance of your agents against the player who uses the basic blackjack strategy. Policy analysis. Discuss some interesting policies learned by the agents. For example, you might observe the agent has learned to always stand when the sum of its cards is 20 or 21, which aligns with the optimal human strategies. And here is the list of references we are referring for our project, which these includes the work of planning and strategy of a game and reinforcement learning strategies. So thank you everyone, and special thanks to my supervisor who gave me an interesting project for me to work on reinforcement learning for my dissertation. Thank you, John. Thank you, everyone.